Section 6.5, theorems about roots of polynomial equations. We're going to solve an equation using the rational root theorem, and then we'll get to the second objective later on. The rational root theorem is just a way to help us factor polynomial equations and find the zeros. Now, we've already learned how to factor some polynomial equations, such as quadratics. We learned the quadratic formula, we learned how to factor, we learned how to graph to solve. So then the question happens, what happens when we have a polynomial that we can't factor, something higher? How do we find the zeros or solutions to our equation, and how do we factor a polynomial equation? Well, that's when the rational root theorem comes in. So if we have some polynomial equation, this is just a general notation for a polynomial, then the way that we can find possible rational roots is by using this P over Q. So P over Q is a rational number in simplest form and is a zero of y equals f of x. So if it is a zero, then P is a factor of a sub n, which this is a sub n, which is your constant, and a sub 0, and so Q would be factors of a sub 0, which is your leading coefficient. So again, P represents factors of the constant, and Q represents factors of your leading coefficient. So this is what we're going to be doing for a lot of these problems. And when you're doing factors of the constant over the leading coefficient, what you're doing is you're finding all the possible rational roots of the polynomial equation. Now, let's kind of go to a problem that we do know and we've seen before. So this polynomial equation that we have right here, 3x squared plus 8x plus 5, which is a quadratic, we learned how to factor these by using our slide and divide method. We took the 3, multiplied it by the 5, and then we found factors of 15 that add up to 8, which are 5 and 3. Then we divided by the number we originally moved, which was 3. And notice that what we were really doing was finding factors of 5, or actually in this case 15, and then we divided those by this number right here. So the constant over our leading coefficient is what we were really doing. So our constant in this case is 5, our leading coefficient is 3. Remember, you always want to be in standard form when you do that. So P over Q would be factors of 5, and so we want plus or minus each of them. So factors of 5 are 1 times 5 gives us 5, and those are the only factors that we have, and 1 and 3. So if we actually write these out, we would have plus or minus for each of the numbers, 1 and plus or minus 5 over 1, which is 5, and then we have plus or minus 1/3, and plus or minus 5/3. So these would be my possible rational roots. And remember, what's a rational number? A rational number is a number that can be written as a fraction, so it has a terminating decimal, or if it's a repeating decimal. So if these are the possible rational roots, what we're going to be doing with polynomial equations that we cannot factor is we're going to say, well, let's see if we can find the solutions and see if we can factor our equation. Well, for this one, when you're finding your solutions, it's easy because you can factor and set it equal to 0. So you get 3x plus 5 equals 0, and x plus 1 equals 0. So here you got x is equal to negative 5/3, and here you got x is equal to negative 1. So I know that these are the solutions to my equation. If I were to do synthetic division, I know that my remainder would give me 0 because they are factors of my equation. This is my linear factor, and this is my factor here. So what we're going to be doing is doing this with equations that we can't factor, and we're going to end up plugging them into our calculator, and we're going to look at our graph for these to help us factor them. So it's kind of hard to see there, so I would probably zoom in just to get a better idea. So if I zoom in, I can check my factoring and my solutions by doing second trace and hitting the value button. So if we do negative 5/3, because that was one of my zeros, notice I get it's on my x-axis, so it's solution, and my y value is 0. And if I do second trace value of negative 1, I would also get 0. And again, that tells me that if I were to do synthetic division with it, it would help me factor my equation. So that's pretty cool that I can use my calculator and use this possible rational root theorem to help me factor things that are not so easily factorable, such as this quadratic equation. So even just to show you, if I did synthetic division with negative 1, So if I do synthetic division with -1, notice that I get my other factor. So my factor here would be x plus 1, because remember, it's always x minus a 0. And notice I get 3x plus 5, which is what it originally factored into over here. So that's pretty cool that we can use this in order to help us factor polynomials that, again, are not quadratics. So if I go back to my paper, let's go down here and do some practice. So for the first one, it says we want to list all the possible rational roots. It didn't say to find all the possible rational or all the actual roots. We're just listing the possible rational roots. So those are the key words right there. If I want to list the possible rational roots, first I have to find what factors of a constant are and factors of the leading coefficient. So in this case, my constant is -3, but I don't really need to write -3 because we're going to take care of that with our plus or minus. So if you want for right now, you can write -3. And my leading coefficient in this case is 1. So if I want factors of 3, what are factors of 3? 1 and 3. So that's your P over your Q. So plus or minus factors of 3 are 1 and 3. And factors of the leading coefficient are just plus or minus 1. I can't leave my answer like this. I want to write them all out. So you always take whatever's in your numerator and put it over your denominator. So this would be plus or minus 1 over 1, which is just 1, and plus or minus 3 over 1, which is just 3. So these are my possible rational roots. So the next step then I would do is figure out which ones are the actual rational roots and then use that to factor my equation, but it didn't ask me to do that for right now. So let's look at example number 2. For example number 2, it says list all the possible rational roots of this equation. So my constant, which is right here, and then I have my leading coefficient, which is 6. So I want my P over Q, so plus equals plus or minus factors of 5, which are just 1 and 5, and factors of 6, 1 and 6 and 2 and 3. So because 1 times 6 is 6 and 2 times 3 is 6, so 1, 2, 3, and 6. So each of the numbers in my numerator has to go over my denominator. So when I write this all out, I'm just going to write plus or minus in parentheses so I don't have to write plus or minus like I did up here for each of these. So plus or minus 1 over 1, which is 1, and 5 over 1, which is 5. And then I have to do 1 over 2, 1 over 3, and 1 over 6. So that would be 1/2, 1/3, and 1/6. And then 5 has to go over everything as well. So 5, and I could have done 1 over 1, 2, 3, and 6 first, and then 5 over 1, 2, 3, 6. Doesn't really matter. So the next one's going to be 5 over 2, 5 over 3, and 5 over 6. So again, these are the possible rational roots. And if you ever have ones that are duplicated, you don't need to write them, you just need to write it once. So again, all I did was take the numbers in my numerator and write them over numbers that are in my denominator. Now that we know how to find the possible rational roots, we can use this to help us actually find all of the actual rational roots of our polynomial equation. So this is the steps that we're going to do. For the first one, it's going to seem like a lot because I'm going to have you guys actually write out all the steps because you need to be able to use it when you're doing your homework as a good example. So the first thing it says is find all the roots of 2x cubed minus x squared plus 2x minus 1. So the first thing I want to do is list the possible rational roots. So if I want to list the possible rational roots, remember that's when we're doing our P over Q, and remember P is factors of my constant, so factors of 1 are plus or minus 1, over Q, which are factors of my leading coefficient, which is 2, so 1 times 2 is 2, and those are the only factors. So if I write this all out, I have 1 over 1, which is 1, and 1 over 2, which would be plus or minus 1/2. So these are the possible roots. Now that I have the possible roots, I need to actually test the possible roots using the remainder theorem. So the way that we do this is we're going to plug our equation into our y equals. And so that's the first step that I'm going to do. So I'm going to go to my calculator. And you guys should also be doing this because this is something you really need to practice. So in my y equals, I'm going to put my equation. So 2x cubed, and then minus x squared plus 2x minus 1. So let me make sure I did that right. 2x cubed minus x squared plus 2x minus 1. I suggest always checking to make sure you plugged it in correctly because a lot of times these problems are missed because it's plugged in correctly into your calculator y equals. So now that we plugged it in there, I always like to hit zoom 6 to look at my window. So when I'm looking at this window, I'm trying to figure out which one of my possible rational roots is an actual rational root that I have. And if I look at these possible rational roots, then notice that if I look here, I don't see any negatives on this side of my graph. I only see one answer, which is right here. And that one answer, it looks like 1 is right here, so it's a little bit less than that. So I can tell just by looking at this that it's probably going to be positive 1/2. So if I hit second trace and then do the value, oops. So second trace value and do 1/2, notice that I get my 0 right there. So I know only one of them is going to be my answer, and I already found it. There's another way we can also do this by going to second window. You can change this IND which means independent. If you scroll down, change that to ask. Oops. Leave your dependent on auto always. Go to second graph. We can actually plug in the numbers that we want and it'll give us our y values. So the next part we're going to do, we just did the second window, changed independent from auto to ask, and then we're going to graph and test the possible roots. So what does it mean to test the possible rational roots? That means when we plug them into our equation, so let's say this equation was f of x equals all of this, I want to find which one is going to be a 0, which we already know because we looked at the graph, but like I said, I'm just writing this all out so that you have it down and can refer back to it. So I'm actually testing, going to test 1, I'm going to test -1 into my equation, I'm going to test negative 1/2, and I'm also testing 1/2 into my equation. Well, I already know that if I do 1/2, I'm going to get 0, so that's my solution. But if we did not know that, we could just use our calculator and plug them in. So if you have numbers in here, like let's say I have 1 is 2, and then if I do -1, I get -6. If I do -1/2, notice I get -2.5, and if I do 1/2, I should get 0 because that's the actual solution to my equation. So that's what I'm doing. I'm plugging these in, and remember by the remainder theorem, if when you plug it in you get 0, then it's a factor of your equation. So I know that the only one is 1/2. So f of 1 is 2. This would be -6, and then this is -2.5. So the only one that works is this one here. I normally, like I said, don't have to do all that work because I can tell by looking at my graph what it's going to be, but this also kind of helps you check. And a nice thing about this, you can't clear these out, but if you hit the delete button, you can delete them that way to kind of clear them out on your own. So now I know that this 1/2 is a 0 to my equation. So then I'm going to write down the actual rational root is x equals 1/2. Now remember that we also like to be able to write these as linear factors. So if I write the 1/2 as a linear factor, I have to write the x in it. So if I go backwards and take the 1/2 to the other side, we'd have x minus 1/2. And that would be the linear factor. A lot of the times we don't like to write x minus 1/2, and we'll talk about later that this can also be written as we know from our factoring, 2x minus 1. And there's a way to tell which one you want to use, which again we'll talk about later. So now that I have this, Why do we want the fact that we know that that's an actual rational root? Because the next thing we can do, if we know what our actual rational roots are, then we can factor our equation by using synthetic division. So the next thing we're going to do for number 3 is use the actual root and factor equation using synthetic division. So since my 0 was 1/2, that's what goes in the box, 1/2. And remember, when you're doing your synthetic division, your polynomial equation has to be in standard form with no missing 0 placeholders, which we are. So then we have 2, -1, 2, and -1. And remember, we add for synthetic division, bring down your first number, which is 2. 2 times a half is 1. -1 plus 1 is 0. 0 times a half would be 0, and 0 plus 2 is 2. 2 times a half is 1, and -1 plus 1 is 0. And this is our remainder. And look, notice that it's 0. If for some reason we did not get 0 there, which you should, that means that either you did your synthetic division wrong or you plugged the equation into your calculator wrong and found the wrong 0. Because at this point, you should always get 0 for that remainder, so be very careful. Now, that factored my equation. So if I write this out, remember the 1/2 can be written as x minus 1/2. And right here, this becomes, if we add our x's in, this is now x squared plus 0x plus 2, but we don't need that 0x, so really this would be written as 2x squared plus 2. So that helped me factor my equation. And now, because I factor it, well, the question was find all the roots. So remember we said that if it's a polynomial degree 3, that means that you should have 3 roots that you can find. Well, we found one of them. How come we didn't see the other 2 in our graph? Well, the reason you didn't see the other 2 in your graph is probably because the other 2 are, that means they're imaginary. So if I solve this right here from when I use my synthetic division, I should be able to find my 2 remaining 0. So if I solve, I get 2x squared plus 2 equals 0. So take the 2 to the other side, I get 2x squared equals -2. X squared is equal to, divide both sides by 2, and I get -1. When I would get rid of an even power, I need plus or minus my answer and take the square root. So x is equal to plus or minus the square root of -1, which is equal to plus or minus I root 1, which is equal to just plus or minus I. And notice that gave me my 2 other solutions. So that means that the roots, so all the roots, or solutions if you want to call them, to my equation are x equals 1/2 and plus or minus I. So now that we found all of them using this rational root theorem. So if I go back up, again, first we listed the possible rational roots, then we tested them in our calculator to figure out which ones were the roots. And like I said, normally don't write this all out, so it becomes a lot easier when you just find, okay, the actual rational root 0. Then I put that into my synthetic division and did my synthetic division to factor my polynomial, because remember, if it's a 0 of your equation, then that can help you factor using the synthetic division. And then from there, I found my 2 remaining roots. Now, if it asks us to factor the equation, notice that this part right here that I have would be by factored form, except for it's not done, because notice that we have a GCF, 2x squared plus 2 can be factored out with a 2. So if I wanted to factor that further, I'm going to rewrite it down here, x minus 1/2 times 2x squared plus 2. Well, I can factor out that 2 right there. So if I factor out that 2, I have x minus 1/2 times 2 parentheses x, and I don't need that extra parentheses there. So this would be, times x squared plus 1. And so if I rewrite this, I have 2 times x minus 1/2 times x squared plus 1. And normally we don't like to have fractions when we write out our equations. So if I distribute this 2, that's where we get 2x, and then 2 times a half would be 1, and then x squared plus 1. So this would be my actual factored form. So if I were to multiply that out, I would get my original equation. And that's what I was talking about before when we don't usually leave our equation like this right here. We usually write this. But how are we allowed to do that? We're allowed to do that because we actually factored out this 2 from this part of my equation and then multiplied it back through. So these are the steps that we're going to learn. And again, make sure you practice it and practice plugging your calculator. So in class, we're going to do example 2, and then we're going to do some more practice in groups, and then we will finish the rest of it and talk about the irrational root theorem and the imaginary root theorem.